Hi everyone, I am Dr. K. Murugan, working as an associate professor in the Department of ECE at KPR Institute of Engineering and Technology. We are going to discuss about some basic optical network components. There are plenty of optical components, for example, couplers, isolators, circulators, multiplexers, filters, optical amplifiers, tunable lasers, switches and wavelength converters. So in this video, we will discuss some basic optical components. The first and foremost component we are going to discuss is couplers as well as splitters. We already know most of the optical components are similar to microwave components. So if I take a coupler which is used to combine as well as split signals in an optical network. If we consider a 2 cross 2 coupler, it will have two input ports as well as two output ports. So next we are going to discuss how to design this couplers. So these are designed by taking two optical fibers and fusing them at the center. They are called fused fiber couplers. So in 2 cross 2 coupler there are two inputs. So what they will do is it will take an input, a fraction that's called alpha from input port 1 and place it in the output port. The remaining portion of the power in the port 1 input port will be placed at the output port 2. A fraction of power from an input port 2, that's called 1 minus alpha, is placed at the output port 1 and remaining input in the port 2 is placed at the output port 2. So here we are defining alpha as a coupling ratio. The couplers can be designed to be either wavelength selective or wavelength independent over a useful wide range. So wavelength independent in the sense the coupling ratio alpha is independent of wavelength. If it is wavelength selective, the alpha in the sense coupling ratio is dependent on wavelength. So next we are going to discuss about a type of coupler called 3 dB coupler. So this is used to distribute an input signal among two output ports equally. So if I am placing a power in the input port, then the power will be distributed equally at the output port. So such kind of couplers are called couplers. So next we are going to discuss about another type of coupler called N cross N star coupler. So they are designed using 3 dB couplers. So as usual, if I am having N cross N coupler, it will have N input port and N output port. These N cross N star couplers are designed using my 3 dB couplers. So power in each port will be divided equally among each output port in this star coupler. So star couplers are used to tap off a small portion of the power from a light stream for monitoring purposes or other reasons. So these are the constructions of my N cross N star coupler using 3. So a coupler can be made wavelength selective as well as wavelength independent. So in general the couplers are used in the wavelength of 1310 nanometer to 1550 nanometers without any loss. So these type of couplers are used in optical amplifiers. Couplers and most other passive optical devices are reciprocal devices, and that the device work exactly the same way if their inputs and outputs are reversed. In the sense, if I am connecting input and the output port, then the same behavior will be repeated in an opposite manner. So in many systems there is a need for passive non-reciprocal device. So such kind of devices are. Thank you.